Um, I hope you guys can see my slides now and can hear me as well.
Yes, we can. Thank you.
Um, so Mangalabat to everyone. Good afternoon. My name is Awal and I am based in Bangladesh. Today's topic that I'm going to talk about is the RPKI deployment status in Myanmar. So I'm going to try to highlight some of my findings in terms of RPKI deployment by the network operators in Myanmar. So before jumping into the topic, let's first take a look about why and how does the resource public infrastructure or RPKI does take place in the operations of internet. We all know that there are a lot of incidents happening in the internet world, and many of them are because of the prefix hijack. And it is very common in routing incident in the global routing infrastructure. Here, I'd like to demonstrate a situation where you see this AS65500. It has a prefix 192.168.0.0/24, and it announced the prefix to the internet, and the prefix traversed to the global routing table to the AS64805. Now this is intended that if the prefix announcement is okay, the return traffic from AS64805 will take this path to the origin AS. But in some cases, if there is an attacker and prefix hijacker, for example, here in this case is 65510, this is tries to announce the same prefix that is owned by a 65500, and it is announcing it to the internet as well. And for some parts of the world, this announcement is going to be the best path for the reverse traffic. So in that case, AS64805, its traffic may take a different path than the authentic one. So in that case, the traffic is going to go to the hijacked network. So since AS65510 doesn't actually have the allocation for 192.168.0.0/24, that's why we are calling it a hijack, prefix hijack, and it's happening in the internet world very frequently. So how can we prevent this? How can we protect it? We can actually try to deploy RPKI, and that can help reduce the prefix hijack. So how RPKI works? It is basically two steps. One is every network operator should sign or create their ROA. The ROA is route origin authorization. It is actually a digital object that is related to a certain prefix which is owned by a certain AS number. And eventually it means that this particular AS number who owns the legitimate prefix is only authorized to announce it in the global BGP table. And the second part of RPKI is validating the ROAS, or we call it route origin validation. When you create a ROA, it is stored in a repository, and then who wants to validate the ROAS can deploy a relying party software which is called validator. And one of the very popular open source validator is Routinator. Many network operators use this, and there are several others. So the validator, it actually collects all the ROAS and store it locally, and then once you configure validation in your BGP router, the router communicates with the validator and collects all the VRPs, or we call validated ROA payloads, and then it stores it in the router. And when it receives any BGP announcement from its peer or neighbor, then it checks with the VRPs, and if it is a valid route, it accepts. It marks the different status of the routes, and then based on your configuration, it can drop certain prefixes, it can accept it. So it's based on the network admin's configuration, right? So what is a ROA? In very short demonstration here. For example, a ROA actually consists of 3 parameters. One is the prefix itself, 192.168.0.0/24 here in this example. And let's say this prefix is allocated to a 65500, and the admin of the 65500 wants to create ROA for up to a maximum length of subnet of 23. That means this certain ROA covers several VRPs or several routes. For example, in this case, we are creating ROA covering from 22 to 23, which means that we have ROAs for several prefixes and doesn't have any ROA for /24s, right? In this case, you see the red cross mark. This doesn't covered by this ROA. So if you now announce this prefix, even though you are legitimate AS number to announce this prefix, but because you didn't create ROA up to /24 or for this certain /24, it's gonna be marked as an invalid or otherwise called max length invalid, right? So this way you can actually attune your ROAs or VRPs. So how does this take place in the validation concept? Here we have this VRP or ROA configured, and then R1 is receiving several different BGP announcement, and it's now gonna check with the ROAs and whether it is valid, invalid, or not found. So here from the left, bottom left, we have an announcement 100.100.0.0/24 from this AS number. And since we didn't create any ROA, that's why it will be marked as not found, because there is no ROA created for this prefix. At the upper left is the green one, 192.168.2.0/23 from AS number 65500. The router gets a valid ROA for that, because our ROA covers up to /23. That's why it's marked as valid. But if you see particularly for the top 3 one is a 192.168.0.0/24, because the ROA doesn't cover up to /24, even though the AS number is valid, but this has become invalid because of max length. The top one is a /23, which is covered by the ROA, but the AS number doesn't match. That's why it's again origin invalid, right? This route is invalid because of the origin AS number doesn't match with the VRP. The other one is max length as well as origin invalid because of the reason that I explained. So now if you configure to drop invalids, your router R1 is gonna send only 2 prefixes to the neighbor router, which is R2, and it only is sending the not found and valid routes because it's gonna drop invalids, right? So this way we can, configure origin, we can do origin validation in our routers. See some examples here. Here on the top we have 3 announcements, and one is shown as a red square with a key, which means it's an invalid route. And if you check what kind of invalid is it, it's actually an origin AS invalid. At the second example I have, you can see easily that the ROA is created with the max length of 22, but the announcement is made for several /24s, even though the origin AS is okay, but because of the max length, several /24 became invalid, right? Now, what is the status of RPKI deployment in Myanmar? So if you see from June 19 to December 20, I have plotted the graph for the 3 different status for BGP announcements made by Myanmar network operators. So it has a very good progress in terms of valid ROAs, valid BGP announcement. And you see the green one, was gradually increasing after the MMNOG or just before the MMNOG 3 last year, and it was consistently actually growing. But after mid of October, we can see that there is a huge drop of valid ROAS. Why? This is not actually drop of valid ROAS, but it's actually drop of valid BGP prefixes, because there has been a significant increase in of not found ROAS that is marked with green one, the blue one. And why I'm gonna tell you, but at this moment, what I found is the AS number, a particular AS number, is announcing a large number of V6 prefixes that are not covered by any ROAS. So it is like not found, right? But the invalid prefixes is not going away. It is consistently there, but with a very minimum number, right? So we may need to, the network operators in Myanmar need to work to fix these kind of things. And if you see that the increased number of not found ROA is just because one AS number announcing a large number of basic prefixes. I'll dig down more in later slides here. So this AS number is actually announcing about 305. This is 305 prefixes without any ROA. That is approximately 25% of the total BGP announcement in Myanmar. And I was curious whether this AS number is actually generating any large number of IPv6 traffic. So in the APNIC V6 statistics portal, I don't see significant increase in terms of V6 prefixes. So if you see the pattern, there is a large number of /40 BGP announcement from their parent subnet, which is a /32. So probably somebody needs to tell them that they don't need to announce so many 40, but if they want, they can actually create ROAS for each of them, and that would take Myanmar's valid RPKI BGP announcements up to more than 80%, I guess, more than 80%. There are 6 invalid routes right now, and you see the right side of the screen. There's a screenshot that has a /64 IPv6 announcement. That shouldn't be in the global routing table. /64 is not allowed to announce, right? /48 is the maximum is the smallest subnet size that you can announce in global BGP. In terms of the types of invalids, I can see out of these 6, 4 has the max length plus origin invalid. Because of this screenshot, you see, this 4 has origin and max length invalid. And there are others like only max length invalid and origin also. That's not a big number, but easily it can be made to 0 or maybe very minimum number. The routing incidents, I'm glad that Myanmar has improved a lot in terms of routing incidents. If you see for more than 1 year of graph here, you see the number of incidents is actually becoming low. Though there is a peak here, but it could be for some reason, and if you see the trend, it's actually lowering much lower than 2019 or something. So how we can improve the RPK adoption in Myanmar? We can remove the incorrect ROAS. This is very easy, because if the network admin has the knowledge on how the ROAS should be created, the max length invalids can be easily reduced to 0, right? There are BGP announcements that are made with the wrong AS number compared to the created ROA. So the synchronized BGP announcement with the ROA should be done. So what happens in many network operators is that the system admin who is maintaining the MyAPNIC portal and creating the ROA not necessarily takes care of the BGP announcement made by their network team. So there should be synchronized activity. And most importantly, the origin validation should be implemented by the major transit providers in Myanmar. That could actually reduce the number of invalid routes significantly, close to 0, I guess. And good thing is MMIX is dropping invalids, and we are gonna see the next presentation where this discussion is going to happen, how MMIX deployed the route origin validation. But transit providers, I'm not sure, but probably no. So transit providers should take care of this, and that could be a massive step for routing security in Myanmar. So how to deal with it? We can do many different steps, but major steps are here. You create your row appropriately. When you announce PGP prefixes, do prefix filtering, and if possible, do origin validation. And that's all from my side. I hope I could give you a good idea about some of the critical issues that Myanmar is having, and the good thing that is that the incidents is being dropping gradually. Thank you so much. If you have any question.